Hi, everybody. Good afternoon. My name is Marta Bescana. Welcome to another Carto Spatial Spotlights session. I am a solutions engineer, and today I'm going to be talking to you about something that I find quite exciting, which is the use of SQL parameters in order to create your dashboards in Carto. But first things first, something that I wanted to dive in before I start with the explanation is something a bit more basic in order to put you all on the same page with Carto. I'm just gonna start sharing my screen. Okay, let's go. So before we start with the SQL parameters, something that I wanted to remind you guys with, for those that have not used Carto before or are not so familiar with it, this is Builder. This is the tool that you have within the platform that allows you to create dynamic dashboards. And the way you can add data to a map happens in different ways, right? So one way would be only like once you have created that connection to your data warehouse, your data source, you could just come here to the Data Explorer and check on one table that you would like to add, and you just need to click Add Source, and that will get automatically added to the map. So in this case, I selected some locations for Starbucks in New York, and this is what you see. It's just a point data set added to the map. That would be about it. Another way to add data into the map, which is something that offers more flexibility, is to do it so by creating a query, because we have a SQL console embedded into Builder that allows you to run query directly on your data warehouse. So in this case, what I'm doing is basically exactly the same, right? I'm retrieving all the columns in this case for the same table for those Starbucks locations, but I could also only select certain columns, for example. So the SQL console is really something that is allowing you to have like greater flexibility on the data that you want to manage, right? So if you see, if I just hide that layer from the table, you will see the layer that gets added through the query, and it's exactly the same. One is only by selecting a table, and the other one is using the SQL console. Okay, so when this is clear, I can start with the presentation. So let's see how we can leverage SQL parameters in order to create a dynamic index. That is something that is quite useful. But what are SQL parameters? Basically, SQL parameters are going to serve as placeholders in that query that you can put on your console in order to allow viewers or users to input specific values that can dynamically replace those placeholders in order to retrieve only like a certain portion of the data, for example. So the difference between the widgets and the parameters, the widgets are those filters that we can place on a side of the dashboard that allow us to filter data that is already rendered on the map. And it's always associated to a single source. This is something that can be combined with parameters, but the fact that we have parameters now gives us a lot of flexibility, because these parameters, which are like placeholders for our queries, are going to allow users to also like do like a prior selection of the data before it gets rendered on the map. So what type of data formats do we admit as SQL parameters? We have three at the moment. In this case, today I'm working with BigQuery, just for you to know. On the one hand, you have data format, which will allow users to select like a specific time range for which they want the data to be rendered. The other one is text, so you can also like play with categories. For example, if you just want to see data of a certain country, or like maybe like a certain type of vehicle, depending on the data set. But when it comes to categories, this is the one you want to use. And the third one, which is the one that I'm going to be using today, is the numeric data type, which is basically allowing users as well to select like specific values or using specific value ranges in order to control the data that gets retrieved and rendered into the map. So why this matters? Well, I guess like with SQL parameters, we're getting like a more like dynamic map exploration. We can do more things within the map. It's like more entertaining, I would say, and also like you can also get different insights. You can empower the users, the people that you share your maps with, to also derive their own insights from those parameters. Also, for the performance is quite key. For example, in the case that you are working with like a very large data table, if you, for example, select only a portion of the data first, for example, for a time range, that will be the only part of the data that gets retrieved into the map, which will make things more faster. And last but not least, the overall user experience, when having like a dashboard that includes widgets and then also these parameters, makes the whole experience a little bit more interactive and more engaging. So I think users can really like leverage this functionality. So SQL parameters can be used for a very large amount of different use cases, but today what we are going to do is create an index. But it's not going to be a static index, it's going to be dynamic because we're going to have this like SQL parameters. So what basically an index is, for some aspects, like for example, if you're looking to place your new business or maybe to select an area based on certain characteristics, these type of events are not like a one-dimension event, so to say. They are multidimensional. So what we do with indexes is basically we combine like different types of variables that are important for the definition of an area as suitable in order to create a score. The higher the score, it will mean like the higher presence of the variables that we have chosen in a certain area. And something that is always really good to have is the ability to allow or to assign weights to each of those variables, because maybe like for a user, something that is important to have is the presence of a certain segment of the population, but then the fact that there is a lot of traffic or not is not as important. So playing with weights when we are calculating an index, it's always something useful. Okay, so let's go to the map that I have created. Here is my screen. So basically, this is like the area where we are going to focus for a use case that is about urban development. But we are trying to identify our areas that are suitable for development according to certain aspects. Okay, so let's see what type of data we can actually work with. On the one hand, I have all the boroughs in London. I have it here, there are polygons. On the other hand, I have another one that is reflecting the Thames policy area. What else do we have here? Okay, here are like the main centers of activity within London. Another one is areas that have like high accessibility to public transportation, something that is always like nice to have, right? If you're looking for a place to live or to build something. And the last but not least is the definition of areas that are at least within 400 meters of a green site within London. I was happy to see when I loaded the layer that there are not actually many areas in London that are really far away from a green site. Always good. So we have all these different layers, polygons together, and we want to know what areas actually combine all those aspects of being in a certain area or not. But how do we put that all together, right? So what we are going to do here, we're going to use a spatial index as a canvas, so to say. A spatial index is like a very nice data format that we like to work with because it's incredibly light in terms of storage and computing in comparison to geometries, and really allows us to get really flexible on the calculations that we want to make. So each specific cell corresponds to a specific area. And what we are going to do is fill this table with all those aspects that we have mentioned before. So how do we do that? The first thing we need to do is convert those polygons that we have seen into H3 in order to add them to the table. So we have a function within the Carta documentation. This is like the site. You can come and visit with all the, we have an analytics toolbox that comprises a lot of different functions for you to manage and interact with your data. But in this case, because we're using a spatial index, which is an H3, we're going to use, in terms of a spatial SQL, only this one, which is called H3 polyfill. What it does, it basically returns you the H3 indexes contained into a given geography. In this case, are polygons. So when I run this function to each of my layers, I'm going to get tables that are in H3 for each of them. So maybe I can show you one example. I am going to deselect all this because, so if I have, let's see, oh, spoiler, let me just, so if I have the Thames policy area, which is here, and I apply a polyfill, what I will get is some, I forgot to add it into the map, but maybe I can just explain what this, what happens. Basically, this polygon gets divided into those H3 cells that contain all the areas that are covered by this Thames policy area. Okay, so once I have created all those tables with all those three cells, what I am going to get in the end is going to be like a table, the final one, that is going to contain 6 different variables. The first one is going to be the identifier of each H3 cell. The second one is going to be the name of the borough each cell is in, which is important because we want to filter that down later on. And then we're going to have 4 more variables, which is like for each cell, I'm going to know by joining them together, I have gotten the information to know if a certain cell is within like a town center area, if it's in an area that has high accessibility to public transport, close to a green site, or in a Thames policy area. Okay, so once I have created this, let's say, final table, I can start creating my index. So I'm going to show you very quickly what a static creation of an index would look like. In this case, I am retrieving my data from this table here, which is the one that I just showed you. And then we're getting like 3 different columns. One is the H3 identifier. This is what Carto needs in order to render the data on the map. The second is the name of the borough in London. And then the third one is that index that we are aiming to calculate. In order to do that, we have a subquery here that is basically adding all those variables together and multiplying them by a static weight, so to say, that the user can change. In this case, maybe like in a BigQuery console, but each time they would need to do it apart and then load it into Carto. So what we are looking to do is basically find a way in order to change the weights that we assign to each of those variables in a dynamic way. How do we do that? Let's go back to this map. I'm going to deselect some things. And here I'm going to show you what the query on Carto looks like. So I'm going to make it bigger for you to see. Basically, it's just the same query that you've seen before, but instead of having that specific number, what we are having here is a placeholder that is going to retrieve the number that the viewer selects on the SQL parameter. So let's see how we create a SQL parameter on the map. Here we have our placeholders. And then here, if I come to sources, I can click on this button, which says create a SQL parameter. Continue. Here it will give you the option to select what type of data you want to create a SQL parameter for. In this case, for example, it's a numeric one. I click on continue, and this menu will appear. What you need to do here is just fill in the information in order to know to give your SQL parameter like a name to be displayed on the map. You can choose if you want it as a simple slider, if you want it as a range slider, the type of scale, etc. And this will be added directly into the map. So let's open this other section, which is the section that is containing the parameters and the widgets. And now even though I made a spoiler earlier, let's just load the index itself. So what do we have here? We have basically that H3 layer where we combined all our variables, and we have it colored by the index value, right? So from 0, the areas that are more red will be least suitable areas, to really green, which would be like the best areas to develop something, for example. So what happens here is once you have these parameters set, you will have here, you can just like come and copy the SQL name, and you can come to your query and just replace it as I did it here. You replace all those, and then you're ready to go. So if I, for example, change the weight that I give to the fact that an area is in a is highly accessible by public transport, I can just do so, and then the index will get recalculated dynamically in order to give me like a different view of what my score would look like if I would take my variable into account in this way, right? And this is something that you can do with all the variables that you have included in the query and in the table. And I just think like it's a fantastic way to share maps and to let your users interact with the map and even like to get or obtain their own insights. Something that you can also do is basically play with the resolution that you want to be displayed on the first place. For example, I can choose a lower level resolution, and I will get a little bit bigger hexagons. As soon as I start zooming in the map, the data will get more and more granular until we reach the final or the native resolution of the H3 cells that we are working with. So I'm just gonna leave it like this, for example, and now I can come to those widgets. Remember, those widgets were like the element in the map that allows you to filter the data that is already being rendered. So in this case, what I could do is, for example, just select cells within like the higher ends of the score, for example. I can also like play with the different boroughs. So yeah, tons of possibilities. The number of parameters you can include is larger than this. In this case, I just included for simplicity, but you can also like add more, same for widgets. And something else that I wanted to show you is maybe because we are looking at parameters that are just taking into account numeric values, I also wanted to share with you other use cases. So in this case, I have this other demo that is quite nice to look at. It basically features taxi trips within New York. This other demo is basically taking into account data types, and also categories. So if I, for example, want to visualize what is going on between maybe this time range, so you will see that the SQL query gets executed again, and the same for the categories. Let's do maybe only nights. Every time I change something in the parameters, the query gets rerun on a data warehouse and retrieved to the map automatically. And then it's the same. We can also play with the different widgets in order to select. In this case, we're looking at areas where there are more like pickups or drop-offs within Manhattan. And the way it works with the map is as I showed you in the example before. So yeah, that would be it from my side. I'm going to stop sharing. I hope you enjoyed the content. If you have any questions, just let me know. If you want to sign up for a free trial, you can always do it by checking on the Carto website, and happy to see you again. Bye.